Hello and good day, I'm Fatah and our group will be presenting Part 2 Data Mining Project for Telco Customer Churn Data Exploration and Prediction. Before we move on to the detailed presentation, allow me to recap back the overall project progress, where in Part 1, we have covered the first two phases of SEMA method, which are sample and explore, and for this Part 2, we'll be presenting the result for subsequent SEMA stages. I would like to also highlight that in Part 2 of the project, the sample enhancement was done in order for us to demonstrate an impactful data mining project, particularly on sample phases, on implementing simplified sampling with talent data integration, as well as an enhancement to the explore stage with clustering analysis utilizing 9 tool. A bit of introduction for the telecommunication industry and customer retention, where the main point that we would like to highlight is on the customer retention challenges in the telecommunication industry, where it has become an important metric for assessing company performance and longevity. For this project, we'll be utilizing telco customer churn data to uncover underlying factors as well as contributing factors to subscriber attrition. In addition to that, there will be a comparative analysis with the store sales data that was conducted by previous project. When we talk about customer churn, basically this scenario can happen due to a multitude of factors, such as customer not being satisfied with the product or services, they have been receiving more attractive offers from rival companies, as well as adjustment in customer requirement or situation. So our main goal and strategy for this project is to enhance the product as well as service quality, how best that we can improve the customer support, and what are the effective ways to implement the control measurement to minimize the customer retention. There are three key main questions for the business understanding. One of it is what are the characteristics of the customer who churn, how do usage pattern influence the likelihood of churn, and how we can predict churn in advance based on customer behavior. Since the original raw dataset from Kaggle is basically a clean dataset, hence we have modified the data by introducing imperfections into the dataset, such as creating missing values, inclusion of additional attributes on timestamp series, creation of synthetic dataset, basically to realistically simulating real-world data scenarios. This approach also enabled the project to showcase essential data pre-processing skill, such as how do we handle missing values, as well as inconsistency, which is basically critical in real-world data analysis. So these are the methodology of SEMA method that has been employed in the project. We have completed sample explore stages in part 1. However, we do improve our analysis for these two phases in part 2, which we will present in the next particular slide. So the modified dataset comprises of 7,020 records with 22 attributes. We have also enhanced the sampling method from part 1, which previously used random sampling, and in this part 2, we adopt systematic sampling with tailored data integration for further analysis. So this slide is basically to showcase the overall reclassification of the metadata, where the variable roles are already changed to align with the goals of the project, which is customer churn. So we have enhanced our sample process by adapting systematic sampling using talent data integration. So this technique ensures that the sample is both uniform and representative of the entire dataset. This method is also advantageous for its simplicity and effectiveness in reducing bias.
Hey Janchang, I'm talking about the univariate analysis in the explore stage. So our findings are mostly charges and the total charges decrease the value. Long-term customers make up the majority and the data is clean with no outliers. Explore, our findings are gender distribution is balanced. Most users choose to use the internet services, prefer mostly contract renewals, and usually pay by electric check. And then most customers remain loyal, have no dependence, and subscribe to phone services.
Hello, I'm Mohammed Sharafiq, and I'm going to tell you about the bivariate analysis and the clustering part of our project. So from our analysis, we found that customers who have been with the company from a longer period of time tend to have more monthly charges each month. And we also found that those people have like the higher total charges rate as well. In our analysis, we also found that people who have a higher monthly charges tend to churn much often. From this graph, we can understand the relation of churn with the length of contract and the gender. So there are three types of length of contract: month-to-month, 1 year, and 2-year contract. So the customer who have a shorter length of contract have a higher rate of churning, and customers who have like a longer length of contract, like 1 year or 2 year, tend to churn very less. And we also haven't found any significant difference in the churning rate between different genders. Both have nearly the same rate of churn. If we see the first graph in the slide, we can see the gender parity in monthly charges. Both female and male customers have the similar median billing amounts. So the gender doesn't seem to be a factor in how much the customer has to pay each month. Now, if we see the second graph, the phone service versus the total charges, we can see that like having the phone service appears to be associated with higher total charges. Customers who have a phone service tend to spend more each month compared to those who doesn't have a phone service. Now, if we see the last graph, we can see that the customer with the shortest tenure have the highest churn rate. This means like they are more likely to churn and cancel their service within a short period of time. But as the tenure increases, the churn rate drops significantly. In this graph, we can see like how the payment method correlates with the customer loyalty. So in the graph, we can see that the customer who have chosen EasyCheck as the payment method tend to have a higher churn rate compared to the other payment methods. Also, if we see the contract versus the phone service, we can see that the phone service is like popular among those customers who prefer month-to-month based contract over the other contracts.
I'm Saravanan, the next presenter on multivariate analysis in the explore stage. Our finding on scatter plot show that the new client with higher monthly fees have increased churn rate in contrast to a loyal customer with lower fees would churn less. Additionally, the chart in right hand side shows the churn is influenced by payment method. Automatic payment decrease churn while electronic check raise it, irrespective of the contract duration, underscoring the significance of payment option in customer retention. As we delve into our multivariate analysis, let's examine customer behavior and its impact on churn rates. Starting with tenure and monthly charges, there is no strong link to churn. However, it's notable that longer-term contracts are associated with lower monthly charges, which may help reduce churn. Moving on the up payment method, we observe a clear pattern. Customer on monthly contract will opt for electronic checks as their payment method, will tend to incur higher charges, which unfortunately also translate into higher churn rates. Lastly, when we look at the total charges versus payment method in relation to churn, an interesting trend emerges. Lower overall expenses align with a higher churn, implying that a customer with shorter service usage are more likely to leave. Conversely, higher total expenses are indicative of longer-term customer retention. This insight is crucial for strategizing on customer engagement and retention initiative. Our analysis provides a critical insight into churn prediction. The charts show that there is a variation in customer tenure and billing, with most customers having moderate deviation from the average monthly and total charges. This suggests that while there may be a general pattern in customer spending, individual behavior do vary, which could impact churn. When we focus on senior customers, we observe a trend of shorter tenure but higher monthly charges, indicating a higher churn risk among seniors, perhaps due to a perceived lack of value or the financial burden of higher charges. This finding can inform our churn prediction exploration, emphasizing the need for a tailored engagement retention strategies. For senior citizens, targeted interventions such as customized pricing plan or loyalty reward could be beneficial in improving retention. In this phase of our churn analysis, we examine the correlation matrix for variable analysis. The metrics indicate that no single pair of interval variables exhibit a correlation coefficient greater than 0.9. This is a significant finding as it suggests that the multi-collinearity is not a concern for our model, and we can retain all the current variables without risking the distortion in our churn prediction analysis.
So in this project, we have used two clustering algorithms, k-means and dbscan. So if we see the k-means algorithm, we have chosen the number of clusters as 2 and number of iterations as 99. The dbscan cluster more data points into cluster 0, while the cluster 1 with the red color is smaller. Cluster 0 has like the lower charges and the cluster 1 has like a higher charges. So we can see and understand from here that the k-mean clustered based on the cost of monthly charges of each customer. So the customer who has like a higher charges of month is in the cluster 1 and those customers who have lower monthly charges are in cluster 0. dbscan is also one of the most popular clustering algorithms. We use the dbscan algorithm using the Canam software. It clustered the data into 3 groups: cluster 0, cluster 1 and cluster 2. Where the cluster 2 is the largest cluster with 5,946 points, and the other two clusters are smaller, with cluster 1 with 362 points, with cluster 0 with 93 points only.
In modify phase, we will be showcasing how we handle values using talent data integration. So in this tool, we set up the condition in the T filter rule component to filter out records where the total charges column is null. Then we visualize the record with null values in a tabular format by connecting to the T log rule component. And lastly, we also embed T filter rule component again for the component to basically configure to exclude records where the total charges column is not equal to null to ensure that the completeness and the quality of the entire dataset. So if we refer in this workflow of how we handle the duplicate records, basically we have embedded the deduplication in talent data integration by splitting the data with unit records using T-log row and then save the preprocessed file in the T-file output delimited component.
So for the data transformation in the modify stage, convert the Churn dependence pattern to binary format represented by 0 and 1. Use one hot encoding to process columns such as the internet service, payment method, normalize the monthly charges, total charges, and discard the customer ID column and classify or bucket the tenure column. In the model stage, we split the data into training and validation in a ratio of the 70 and 30 to select the best model from the candidate models. So next is the decision tree. We found that the maximum absolute error of the decision tree model is 0.925 and the average square error is 0.13. So contract has the greatest impact on predicted churn, followed by total charges and the internet services, while the payment method and the senior citizen less affected. Variable impedance is proportionally close between validation and the training datasets, showing the consistency in model performance. So after is gradient boosting, we found that the maximum absolute error of the model is 0.918 and the average square error is 0.130. So showing the prediction accuracy, contract is the most critical predicted, followed by total charges and online security. And then the streaming movies and the device protection have the relatively little impact. So next is the regression model. So the model has a maximum absolute error of the 0.987 and the average squared error of the 0.136 on the validation. So contract is the primary predictor with additional variables incrementally improving the prediction accuracy. Each new variables reduce the validation error rate, enhancing the model's overall performance. So for the neural network, the maximum absolute error for the model is 0.986, so marking the biggest prediction mistake. Average squared error is 0.132, so averaging out the squared prediction inaccuracies. Both metrics gauge the model's prediction errors on the validation set.
In the time series analysis for churn prediction, we observe the relationship between customer tenure and charges throughout year 2021. The fluctuation in the data may signal underlying trends and patterns potentially impacting churn rates. The left-hand side graph shows a visual correlation between tenure and total charges, suggesting that the changes in the tenure could be linked to the variation in total charges over time. On the right-hand side, the histogram compares tenure-based charges on reveals that tenure 2 has consistently higher total charges than tenure 1. This insight is pivotal for churn prediction as may indicate a segment of customer that despite higher payment could exhibit loyalty or a customer's propensity to churn due to a financial burden. Identifying such nuances allow for more targeted retention initiative and personalized communication with a higher risk customer. In our analysis for churn prediction, the regression model outperforms other models in terms of accuracy. It has the lowest maximum absolute error at 0.987, which means it has the smallest extreme errors compared to other models tested. Furthermore, it has the lowest average square error of 0.136, enhancing its credibility for overall prediction precision. These metrics are critical as they suggest that the regression model is most reliable for predicting churn based on the validation dataset. Whereas the ROC chart confirmed that all predictive models perform slightly better. Notably, gradient boosting and neural network models show exceptional performance as they are positioned closer to the left corner of the ROC chart, indicating high sensitivity and specificity as the key indicator of the model's ability to accurately identify churn. The score ranking plot emphasizes the strength of the gradient boosted model, which leads the pack particularly in early depth percentage. However, comparing to accuracy, precision, and ROC, the score ranking plot overall suggests that the regression model is the best fit for this prediction. In conclusion, our churn prediction project has yielded substantial learning outcomes. We began with a comprehensive dataset overview, adapted our initial dataset to better reflect real-world complexities, and focused on targeting high-risk customers and providing competitive, flexible pricing options. We explored the utility of various data mining software such as SAS Enterprise Miner, Talent Data Integration, and NIME, each offering unique advantage in data processing. The exploration and modification phase was crucial, enabling us to uncover trends that inform industry-wide strategy decision and manage complex datasets effectively. Through the model performance comparison, we assess and evaluate different machine learning models, paying a particular attention to the time series analysis, which provided us with a deeper insight into how churn evolved over time. Finally, we considered how to enhance customer service, exploring various solutions to minimize churn and improve overall customer experience. Our project not only improved our analytic skills, but also positioned us to make a tangible impact on customer retention strategies. Thank you, Doctor, for your time and attention. If you have any comments or suggestions for improvement, please contact us at your convenience.